Good evening, sir. Jesse Crawford here. Uh, I'm going to go over my video reflection for Mod 3. First, I'm going to start with explaining the experiments that we had tonight or this week. First was the molecular formula lab, where we took copper gluconate and added some sodium chloride 5% or 0.5% sodium chloride to a solution, created a solution. We added a couple washers and then watched as the copper was being extracted from the compound and attaching itself to the washers, and then took out or scraped off the washer from the copper and determined how much copper was within inside that 20-minute period that we were able to extract from the compound. The next one, we went and used the same kind of setup with the flame and the ring and whatnot, and was melting three compounds to see which one was the faster. Starting with a guess, just on the basic the sugar, the salt, and the steric acid ones. From my personal experience with cooking and whatnot, I went with the start. With just looking at them, I went with sugar based on just I've seen sugar melt. I've melted sugar for candies and whatnot, and then I assumed and I predicted that the sodium chloride or the salt would not melt based on just using it and cooking again, where I've placed it in there and it not being dissolved or anything, like sprinkled on some steaks and whatever. And it doesn't leave like a hard crust like sugar would. If I place sugar on it, I melted sugar, I'd probably end up with little sugar spots where it melted on my steak, which would be weird. Then as I poured it onto the little cupcake washers or cupcake wrappers, I noticed when I did the steric acid that it seemed to take a lot to get to 1 gram of it. Basically meaning that it's less dense than the rest. It was bigger pieces, but it's probably more filled with more air, I guess. Like they weren't as thick, weren't as dense, like compacted in or whatever. So I started to assuming that would be the one to win, based on simply that it would just melt away, and whatnot. As far as the things that were specifically addressed in this, the thing was hazards in general, having the flame again. So tonight with this experiment, instead of doing it at my table, with the wooden table, I took it to my kitchen where I have it's made of some sort of rock, I don't know, granite of some sort. Took it and I placed it actually within a foot of my sink, and right above it was off to the right a little bit was my fire extinguisher, prepared for any kind of incidents I may have, to ensure trying to keep the beaker on the ring. Obviously, I don't want to touch it while it's happening. But if anything was to happen, I have the sink right there. I also have my sink. I'm able to clean up any spills and whatnot, and ensure that I can keep it from going in or going anywhere, causing any issues. That is. The results of my experiments. For the first one, it said you'll stop seeing bubbles, the gas bubbles happening. Then you realize that it would be over. The reactions would be done. Well, I never saw that happen or end. I never saw the bubbles end, so I just went to the 20 minutes. I stopped. During it, though, I did observe like the solution get clearer towards the washers, and it was darker away from the washers, and it basically just I assumed that the compound is completing its reaction at those points, because that's what said it would be done after it's clear. So you can see around the ring it was clear, whereas outside of it was still the darker color, the blue, and whatnot. As for the solution, I was unable to get an actual reading from the copper when I measured it. I got 0.00 grams for my reading. If I had a scale that would go 2 or 3 more significant digits past the zero, or past the dot, I mean, I'd be able to tell what my percentage is, what my reading came out to be. So with it getting 0.00, it tells me that it's less than 10% of the actual compound that's within it. So it could be 9, it could be 8, it could whatever. I don't know. So maybe it was. It would have weighed out at 0.09 of the 9%. But I can't. I didn't figure that out. I couldn't get it. My scale wasn't good enough for that. Which leads me to my error portion of this. Errors that could have happened when I was taking the washers out out of the glass. A little bit of it fell off. The copper fell off. I did whatever I can to get that copper into the thing, but I wasn't able to get all of the copper out of the glass. It wasn't very much, but again, I wasn't able to get all of the copper out of the glass. And then when I was drying it in the oven, and I pulled it out and I let it dry, or I let it sit to get to room temperature. I don't know if I cooked it too long, or let it sit too long on the washer or on the cupcake holder. But a little bit, some of the pieces stuck. As far as the other experiment, my results were outrageously ahead. Like nothing could beat it. But the stearic acid was took 8 seconds when it first started to melt, and it was 49 seconds for the entire gram or 1 gram of stearic acid to melt. The sugar came in second at a 2 minutes 15 when it first started to melt, and it never finished melting the entire thing. And then the sodium chloride never got it to melt at all, like I predicted. The sugar, one of my errors would be basically the sugar. When I put it on the flame, I realized that it was a heaping one. When I started seeing the melting, I realized it was just the outside part. So I kind of tried to like shake it a little bit to level it out. It helped a little bit, I guess, but not that much. It still would have not beat the 49 seconds for the stearic acid, but I went ahead and leveled out the other ones. Salt again never melted. The covalent bonds were for both the sugar and the stearic acid. As we can see, just looking at the formula, with both of them having carbon, hydrogen, and oxygen, both non-metals, and then the sodium chloride having a metal. It's an ionic compound. As for understanding the module outcomes for this, and what I achieved and what I struggled at first, I was like, why did the stearic acid just blow everything out of the water and take 8 seconds to start melting, basically. 8 seconds is when I looked at the clock. I mean, it started melting immediately almost. And then I went ahead and I was looking at the formula again, and I went and researched melting points for these 3 elements. And I got hydrogen at a negative 435 Fahrenheit, oxygen at negative 361 Fahrenheit, and then carbon at a 6,381 Fahrenheit. So that's a big difference between hydrogen and carbon. And then looking at the formulas again, I see that both of those have the stearic acid and the sugar, the sucrose, has a carbon, hydrogen, and oxygen in it. They're the same exact. There's just different numbers of them, the amounts of them. Hydrogen had 36, which is 14 more hydrogen than the sugar did, and only 6 more carbon. Just not enough, I think, to maybe to make up for the difference between the hydrogens. And the hydrogen again melts extremely fast at this temperature that we were using here, negative 435. So it seems that the hydrogen having so much was able to overcome the carbon on the other side and melt it pretty fast. Connecting back, I mean the lecture, it's basically taking these, laying them out, and combining them together. Well, that's my reflection video. I appreciate your time.